Hi guys, I'm Ernest. Welcome to our channel of Sciences and Mathematics. Today we are going to look at a different version of course, the mean value theorem, which is basically a special case that we are going to refer to Rolle's theorem. Now in this case, we said that it's good for us to try and appreciate some of the applications of these specific concepts that we were trying to discuss in our videos. Now in this case, we're going to see that the Rolle's theorem is very much applicable in trying to figure out how the motion, of course, in two-dimensional space, like the projectile motion that we have talked in one of our videos, can be able to be described, especially in trying to find the maximum height of some of the projectiles, or maybe trying to describe a trajectory of a projectile motion. So in this case, of course, we're going to find other applications in elliptical domes that are constructed maybe in architectural work. And lastly, we can be able to see this application in electromagnetic waves and sounds, especially in understanding their behavior. So Rolle's theorem is a different version of the mean value theorem, which of course is very important and relevant, as we have seen from some of the examples that I've given. Now in this case, we're going to use the figure on the board that I'm going to use for illustration in trying to find out basically how this different version of the mean value theorem can be able to be interpreted. So without further ado, thank you and welcome. So as I've said, of course, we're going to look at the concept of Rolle's theorem. And as I've said, Rolle's theorem is a special case of the Lagrange's mean value theorem that we have already discussed in one of our videos. I'm going to put the link of the video in the description box so that we can be able to figure out. And before forgetting, of course, in the description box, of course, there is a range of videos for mathematics, chemistry, biology, and physics. So in this case, we're going to use some color codes in illustrating different topics. For mathematics, we're going to find that there's an orange color, physics for gray, and then blue for chemistry. Under mathematics, we're going to see that it's orange in color, and then biology, it's going to be green. So in case, of course, you want to check out in one of our videos in our channel, you can be able to use that color code in order to find the videos, especially for the thumbnails that appear on your screens. So without going further, therefore I'm going to use the illustration on the right side of the board to try and illustrate this. So basically, suppose we have a function that is like that. We can have the points A and B given as that, and this is a y-x Cartesian coordinates system, and this is the point of origin O, and this is our function f of x that we have illustrated as such. We can have another point for C given these specific points as that one. So in this case, as we have said, Rolle's theorem is a special case of the mean value theorem. We're just going to give it as a statement so that we can be able to interpret what basically it refers and give it a geometrical interpretation on the right side as I've drawn. Now, Rolle's theorem has similar conditions to the mean value theorem that we had, of course, said for the first two, but we're going to see the difference for the last one. Now, I'm going to read it. It states that if a function f is defined in the closed interval ab in such a way that, first condition, f, which is the function, is continuous on the closed interval ab. Number two, the function is differentiable on an open interval ab. And the last one, if f, the function of f at a and b is equals the function of f b, then there exists at least one value of x which is given as c, such that the first derivative of c is equals 0. So basically it implies that at these specific points we have f of a, f of c, f of b. So the gradients or the derivatives at these specific points can be defined as f prime of a, f prime of b, and f prime of c. And there's a condition which have been given for the Rolle's theorem for the f prime of c, which states that if f of a is equals f of b, then there exists at least one value of x c such that the f the first derivative of c is equals to 0. So we're going to see that from the above graph, we can see that the function f of x that I've illustrated is continuous on those specific points, and it's differentiable now that we can be able to find a derivative at that particular point c. Now we're going to use an example in trying to figure out whether the n function that we're going to give out obeys Rolle's theorem by trying to figure out whether the three conditions in totality have been obeyed. So I'm going to give an example that we're going to use in order to find out whether that particular function obeys Rolle's theorem, just a similar way as we did for the mean value theorem. Now, just to mention, of course, Rolle's theorem, of which we have illustrated as a special case for the Lagrange's mean value theorem, developed over time, whereby this particular theorem was advanced by Joseph Louis Lagrange, and that is where the mean value theorem, the definition for the mean value theorem came from. Now, later it was proven by the individual that we have mentioned on the board, that is Rolle, who basically simplified the form only for polynomials and assumed that the last condition that we have given for fa and fb exist. But later we are going to also to discuss, maybe in another video, how it was proved by Agustin Cauchy. So in this case, from this particular question that we are going to discuss, it is states that determine whether the function y is equals x squared plus 2 for the intervals of the range -2 and b2 obeys Rolle's theorem. So the first thing that we're going to do is to try to confirm whether it obeys the other conditions that we have, of course, stated. And the first one is going to find f of a and the f of b and try to see whether it is obeying Rolle's theorem. So for us, we just do a substitution for f of a. A is negative, so basically f of a equals this is -2. So this one will be equivalent to, if we do a substitution, -2 squared plus 2, which is equivalent to 6. So basically that is 4 plus 2, which is 6. And then we do for b, fb. So the value for b is 2. This is going to give us 2 squared plus 2, which is going to be 6. So from these two sets of equations that we have solved or done a substitution for a and b respectively, we see that f of a is equal 6, which is equivalent to f of b, which is equal 6. So this one satisfies the condition that we have talked about in the last statement, and we had said that f of a is equals f of b. Then under this condition, there is going to exist at least a value for x in such a way that the first derivative of that value is going to give us 0. And basically that value is going to exist within the range of numbers that we have been given. So therefore it's going to be a set, the value c is going to be a set of -2, 2, that is for a and b, in such a way that the first derivative of c is equals 0. Now if we try to look at this specific equation, we're going to have f of x given as x squared plus 2, whereby f prime of x is equivalent to 2x. So if we substitute x for c, we're going to have f prime of c equals 2c. And in trying to look for the condition under which we are going to have f prime of x equivalent to 0 for it to obey Rolle's theorem, then the value for c is going to be equivalent to 0. Therefore, this value 0 is going to be a set of numbers of the range of AB that we have given as -2, 1. So suppose we had a graph for -2, 1, then therefore 0, basically literally to say 0 is going to fall under that one, and therefore that one implies that it obeys Rolle's theorem for the first, second, and third condition. So basically this is how we're going to try to treat other similar question that we're going to come across, that it basically pertains to the concept of Rolle's theorem, which is a special case of the Lagrange's mean value theorem that we've already discussed in one of our videos. So basically, as we have said, there's this particular discussion is very relevant because it's going to find applications in some of the areas like physics that we're talking about, motion in 2 dimension, basically, which is a projectile motion, and some of the elliptical tools that we may come across in curves that we need to solve for, and maybe sound waves or maybe electromagnetic waves that are going to exploit this concept of Rolle's theorem. So that is it for today, guys. I hope that this is going to assist us, of course, in conjunction with other discussions that we are having to try and figure out how we can be able to solve problems relating to those particular applications. So that is for today. Thank you. Bye. God bless.